Bismillahirrahmanirrahim. Chapter number 1, lecture number 8, grade 9 chemistry. In our today's lecture, we shall discuss chemical formula. Chemical formula means the formula of a compound. And we have in our previous lecture discussed a compound is a combination of two or more different atoms. For example, H2O, carbon dioxide, sodium chloride. These are the compounds. And as you see, hydrogen and oxygen or carbon and oxygen are the symbols of atoms or elements that are part of these compounds. Here H2O or CO2 or NaCl shows the chemical formula for compounds. So what is a chemical formula? A chemical formula is a shortcut name for compound. A shortcut name means that a chemical formula is made up of symbols of elements written side by side. As for example in H2O. Here we write H2 by the side of O, and H stands for hydrogen and O stands for oxygen. So this formula shows that the compound of water has two hydrogen atoms, one oxygen atom, and H2O shows a shortcut name, a symbolic representation of the elements present in the compound. There are two types of chemical formula: empirical formula and number 2, molecular formula. Empirical formula is also called simple formula. Empirical formula is also called simple formula, whereas molecular formula shows the exact number of atoms in a compound. Empirical formula shows it gives two types of information about a compound. For example, if we have C6H6 benzene and C6H12O6 glucose, and their simplest form is CH and CH2O, then C shows the same ratio as in C6H6, and CH2O shows the same ratio as in C6H12O6. That is 1:1 and 1:2:1 by mass. So what is the difference between the two formula? Only there is one difference. In all other respects they are similar. For example, in empirical formula we can see the simple ratio between the atoms. As you can see here also, the simple ratio between carbon, hydrogen and oxygen. And another thing, it also shows the types of atoms. Which type of atoms combine to form benzene or glucose. So these are the simplest empirical formula of benzene and glucose. Molecular formula tells us one more thing. It gives us three information. Two similar to empirical formula, that is the ratio between the atoms and the types of atoms. And one more information is that it tells us the exact number of atoms in a molecule. Exact number of atoms. Here in benzene, the exact number of carbon is 6 and that of hydrogen is also 6. Similarly here, the exact number of carbon in glucose is 6, hydrogen 12 and oxygen 6. So if we write these in other form, the ratio will remain the same. A is here 1 1, but this is not the formula of benzene. 7 is not the exact number of the carbon and hydrogen in the formula, molecular formula of benzene. Therefore, it is incorrect. Molecular formula and empirical formula are related to one another, and the relation is very simple. The experimental determination of chemical formula, especially molecular formula, is also very interesting and is not so much complicated as our students fear it, but a short cut explanation will be given here. Molecular formula is equal to N2 empirical formula. Where N stands for 1, 2, 3, 4, etc. So on and so forth. One is not so much important. If you multiply anything with 1, it remains the same. But the stool starts with 2, 3 and 4. They are important because if n is equal to 2 or 3 or 4, then it will really change the nature of empirical formula. Because in most of the cases, empirical formula and molecular formula are similar. For example, in case of H2O, carbon dioxide, H2SO4, N2O, CH4, empirical formula and molecular formula are the same. But in case of other organic compound such as C6, H6, sugar, glucose C6, H12, O6, and similarly other carbohydrate, empirical formula will be different from the empirical formula. Molecular formula will be different from the empirical formula. So here the factor n needs to be calculated experimentally. How can we calculate it experimentally? Experimentally we need only one thing. Suppose we have calculated that a certain compound has two types of atoms, carbon and hydrogen. Its simple formula will be, empirical formula will be 12 plus 1 is equal to 13. As we know that the atomic mass of carbon is 12 and that of hydrogen is 1, so its empirical formula weight is 13. And similarly, experimentally, we will need to calculate. This is the empirical formula weight. Experimentally, we need to calculate molecular weight MW. Suppose we get NW 78. So N can be calculated by molecular weight divided by empirical formula weight. Molecular weight divided by empirical formula weight, 78 divided by 13, which comes to be equals to 6. So n becomes 6. Then we can write, we can use this formula, molecular formula of CH is equal to N into CH is equal to 6 into CH is equal to C6H6, which is the molecular formula of CH. So molecular formula can be easily calculated if we can determine experimentally the number, the types of atoms in the compound in the simple formula, and further the molecular weight by another method experimentally. Thanks for watching.